Hi, and welcome to BH Sensor's demonstration of our multi-sensor platform. I'm very excited about this particular demonstration because this really will show a new paradigm in sensor systems and how sensor systems can be used to advantage in many different applications. What you see here is 6 sensors, they're proximity sensors, that are all daisy-chained together via RJ45 cable that goes to a master controller board, which then relays the data that is gathered from all the sensors to the end user, be it a computer, a laptop, or even a smartphone. This particular configuration uses Ethernet connectivity. There is the ability to have this Bluetooth enabled as well. Some of the advantages that might not be so obvious at the outset are, one, that a number of different sensors, proximity sensors here, can be connected along a single cable. That's very useful in area applications such as mining, cargo ships, even aircraft carriers, where the logistics of routing cables as well as cable bundles, cable weight, make a real difference. So it's much to the advantage of the user to have multiple sensors all riding, as you see here, on a single cable rather than each sensor having its own cable. But let me show you this in action, where you can clearly see as the ball rolls down the curve, each sensor picking it up as the ball passes. It's interesting to note also, I'll do it again, that the time difference between sensor number 1 and sensor number 2 is longer than the time difference between sensor number 5 and number 6, and that's simply because the ball is traveling faster, and so therefore the sensor picks it up more quickly. This is all very good and well for, as I mentioned, 6 particular senses of one kind. Our technology is such that we have the ability to mix and match different kinds of sensors. So we are not limited to having 6 proximity sensors all daisy-chained. We have the ability to add in other types of sensors. I'll show you that in a minute. Okay, so what I've done now is I've replaced this rail under which we roll the ball over the proximity sensors, and I've replaced it with this arrangement here. This arrangement here has a number of different type of sensors. It has the regular proximity sensor, it has a pressure sensor, it has a force and vibration sensor, it has an angular displacement inclinometer sensor, it has a switch, and it has another sensor for sensing material. Notice the entire sensor system, the electronics, has not changed at all. It's identically the same. What I've done is I've introduced a change in mechanics of the device, which allows me to get a number of sensors. In fact, if you think about it, there are about 15 different sensors that are shown here that are now integrated into a single sensor system. Again, with all the advantages we talked beforehand, single wire, logistics routing, etc. So now one goes from a single type of sensor now to sensors of varying capabilities and applications, in which now entire systems and platforms can be designed and built. For example, an entire factory can be sensorized with all these different sensors on a single platform. An entire ship can be sensorized with various different sensor types. For a injection molding process can be entirely sensorized for pressure, force, temperature, load, etc., with a single system. Each one of these sensors can be pulled out and replaced, hot swapped in and out to suit the particular mission and need of that particular application. So let me show you these sensors quickly of how they behave, and you'll see the powerful paradigm shift in sensor system design based upon BH Sensors technology. So here is the original proximity sensor, and as you can see, it performs the usual proximity function. The next sensor on the list, let me stop this one. Is the pressure sensor. Here I apply a pressure to a diaphragm, and as you can see, as I press on this bulb, I increase the pressure inside. So now you have a pressure sensor as well as a proximity sensor. Let's move on to the next sensor from here. This sensor here, the third one, is a force sensor. So for example, I can measure weight as well as vibration. You can clearly see the vibration of the cantilever beam that is holding the weight. The weight, of course, is due to the quarter coin. And then, of course, it goes back to zero. So now I have a proximity sensor, a pressure sensor, and a force, vibration, weight sensor, all in the same system. Let's move on to the next sensor from here. This sensor is an angular sensor where I can measure the angle of whatever it is that I'm turning. In this case, it's a rotating cylinder. And so I can get my angular rotation. And so therefore I get angular displacement, inclinometers, etc. out of this. Moving on to the next sensor from here, we'll have just a simple switching device. So for example, something that is a, for example, as a butterfly valve, some non-contact particular device that you want to control. So here you have your on condition, off condition, on condition, off condition, and the like. Again, very simple. And finally, the last sensor that we have is a device that will measure material properties. So for example, if I go ahead and I have a syringe of water, and if I apply water to the sensor, you can clearly see that it picks up water. If I remove the water, the sensor slowly comes back as things evaporate and the like. Again, I can add water to the sensor, and again you see the water pickup. So now let's sum up everything that we've seen here. So what we've demonstrated here is this multidiscipline sensor platform. Again, proximity, pressure, force and weight, angular displacement, on and off, and water, non-water measurement, material measurement. Again, the same platform, the same electronics, the same communication protocol. Everything is identical. We've simply changed the individual mechanical aspects of the device so that we have multi-sensors. What this does on a general term is there's no longer a need for multiple manufacturers, multiple sensor manufacturers, to be able to provide sensors in a total system. For example, one does not have to go to manufacturer X for a proximity sensor, manufacturer Y for a pressure sensor, manufacturer Z for a force sensor, and then try and combine them all into one particular system. Here you have a fully integrated, fully multidiscipline sensor system, which by mixing and matching and customizing the kinds of mechanical interface with the system, we generate multiple sensor capabilities, sensorization of entire systems now. In addition to this, one has the usual aspects of systems. For example, not every sensor needs to be on at the same time. Not every sensor needs to be poled the same way. Sensors can be of different accuracy levels. For example, you might have one pressure sensor 0 to 100 psi, another pressure sensor 0 to 5,000 psi, two force sensors, one measuring 1 gram, one measuring 1,000 kilograms. All can be integrated within the same system with the usual system parameters of control, command, and data gathering. Hope you enjoyed the system. Enjoy.